Now we're diving to the heart of this unit, kinematics. All the discussions we've had so far, like scalar and vector quantities, the concept of change, and rate of change, are all building up to this topic. So, what is kinematics? Kinematics is all about describing motion without worrying about what's causing it. To describe motion accurately, we need two fundamental physical quantities, time and position. From time, we can get to change of time by looking at the initial and final time of the motion. The change of time, often written as delta t, is simply the difference between the final time, t1, and the initial time, t0. Here's a quick note. Time is a physical quantity, and change of time is also a physical quantity. In this course, we will use the variable t to represent the change of time, the difference, rather than the actual time. So, while many people use delta t to talk about the change of time, we'll just use t instead. Similarly, from position, we can figure out the change of position by looking at where something starts and where it ends. The change of position, often written as delta x, is a difference between the final position, x1, and the initial position, x0. Just like the change of time, change of position is also a physical quantity, but it is so frequently used that we have a special name for it, displacement. We also give it another variable, s. With the change of time and the change of position, we can figure out another important physical quantity, the rate of change of position, defined as delta x divided by delta t. It tells us how quickly the position is changing over time, which we often refer to as velocity. When we use the instantaneous rate of change, or IROC, we can find the velocity at a specific moment, not just the average over a period. This lets us determine the initial and final velocities more precisely, giving us a clearer picture of how an object's speed changes at different points in time. We label the initial velocity as u and the final velocity as v. Now, if we combine the initial and final velocities, we can determine the change in velocity. With a change of time, we can then figure out the rate of change of velocity, or delta v divided by delta t, which is known as acceleration, denoted as a. If we focus on the solid circles, they capture all the key quantities we've discussed so far. T, S, U, V, and A. These five variables represent the five motion quantities in kinematics.